Good morning, everyone. Today we will start a new topic, indefinite integral. So, indefinite integral is a part of a calculus. So, first of all, we will discuss about calculus. Like, calculus can be divided into two parts. First part is differential calculus. First part is called differential calculus, and second part is called integral calculus. Integral calculus. In integral calculus, again we will divide this part into different types. First part is called indefinite integral and second part is called definite integral. So one by one we will discuss these all parts. This part is called indefinite integral and second part is called definite integral. Now uh, one by one we will decide how we will find the value of any integral, then how we can apply the lower limit, upper limit, then it becomes definite integral. So we start from here. Suppose some curve given and fx is equal to x cube. We can differentiate the curve, then we will get differentiation of fx with respect to dx is equal to 3 times of x square. So whenever we differentiate, this is a part of differential calculus. Suppose someone asks, what is the integral of 3x square? So we can write in this way, integral of 3x square dx is equal to x cube. Now we have some symbol like first symbol, this dx symbol. So one by one we will decide what is the meaning of this all symbol. Before that we will start some work here. Okay, we will take some example, or first we define. So what is the definition? A function fx is called a function, this time I am writing capital fx is called an integral of a function fx of a function small fx if differentiation of capital fx, like if differentiation of capital fx with respect to x is equal to a small fx. You can check this value. In first example, if we differentiate x cube, then we will get 3x square. So if we integrate 3x square dx, then we will get x cube. Then how we can write? So this one is a small f x. Okay. Now in place of integration, we use some term like we can use primitive. We can say primitive. We can say integral. We can use the term antiderivative also. Antiderivative. So meaning of primitive, integral or antiderivative, it's same like in definite or sorry integration. Now we will find what I have written here. If we differentiate, what is the meaning here? Capital fx with respect to x, then we will get a small fx. Now this time we are using some symbol, and this symbol is called symbol of integration. I am implementing some symbol. This one is called symbol of integration. So we can write in this way, capital fx, we write first capital fx here is equal to a small fx dx, like if we differentiate capital Fx, then we will get a small fx, or if we integrate a small fx, then we will get capital Fx. So this is the relation between differentiation and integration, like both of them are inverse of each other. So we can write one more line here. We can start writing integration is the inverse process of differentiation. We can write integration is the inverse process of differentiation. Is the inverse process of differentiation. So we can start from here. Like example, if you differentiate sin x with respect to dx, then we will get cos x. This is the differential calculus or differential. Now we will try to find some relation between differentiation and integration by the help of this example. So we can easily write in this way: differentiation of sin x is equal to cos x into dx. By cross multiplication we can write. Now we can implement some symbol, and this symbol is called symbol of integration. So once we implement symbol of integration on both sides, so we write in this way: d sin x is equal to integration of cos x into dx. Now we can check this. A small symbol of integration means a step by step we add a small particle. This d shows a small particle and this shows summation of these all. So always remember, symbol of integration and d can cancel each other. So this becomes left hand side will be equal to only sin x, and right hand side will be equal to integration of cos x dx. So finally we can write integration of cos x dx is equal to sin x plus c. We can write integration of cos x dx is equal to sin x plus c. Now we use some new term c. So c is called integration constant. This c is called integration constant. I will discuss later why we use this c. So this one is called integration constant. Okay. Now we are using some symbol, like this one is integration symbol. So what is the meaning of this all? One by one I will discuss this all symbol also. First we use symbol. Here if we use some symbol like complete integration I am writing. If we write this type, integration of fx dx, means what is the meaning of this complete symbol? Means integral of fx with respect to x. This is called integral of fx with respect to x. Okay. Here fx is called integrand. What is the name of fx? Fx is called integrand. Fx is called integrand. Next, the variable x in the integral is called variable of integration. Like we are using x here, no? So this x is variable of integration. Variable of integration. Like we can use t. In that case we need to differentiate or integrate with respect to dt. So this x is called variable of integration. Next, if we write the complete value fx dx. Okay, suppose any function is given fx and we need to integrate the function fx with respect to x, then we have to find the value integral of fx dx. The process of finding the integral is called as integration. I'm writing this complete line. The process of finding the integration, the process of finding the process of finding the integral is called as integration. So we can take some example, like if you take for this example, then this x is called variable of integration, this sin x is called, or we integrate this cos x, so this complete cos x is called integrand, fx is called integrand, so this time this complete cos x is called integrand. Now this c is called constant of integration. Why we use this constant c? Because we can check if we differentiate. I am taking some example. With the help of example I will explain. Yes, if you take some example, suppose if we differentiate the value of sin x, then we will get cos x in right hand side with respect to dx, then we get cos x. Now according to our rule, if we integrate cos x, then we will get the sin x, so we can write in this way: integration of cos x dx must be equal to sin x. Okay, again if we write, this is the first example, we take some second example, differentiation of sin x plus some constant c. This time this c may be any constant value, 2, 3, 5, 4, anything. So step by step we will differentiate. So this become again cos x, and when we differentiate c, then we will get the 0 value. Now we can again write cos x dx is equal to sin x plus c. So whenever we use the term indefinite integration, we need to use in answer side one c value, and this c is called integration constant. So this is the basic of indefinite integration. In next video I will discuss some basic formula only with the help of this. Now we will try to go for the basic formula in integration. Till now everything is clear about the symbol, differentiation constant, integration constant, x is a variable of integration, fx is integrand. So now move to the next topic, basic formula. All the basic formula is related to integration only. So till now we will discuss what is the differentiation of x raised to the power n plus 1 with respect to dx. So we can easily write, if we differentiate this complete value, then we will get n plus 1 and x raised to the power n, where n is some constant value or some natural number or some fractional maybe. Okay, we can write, shifting this dx on right hand side, differentiation of x raised to the power n plus 1 is equal to x raised to the power n, and 1 upon n plus 1 can come in left hand side. In this way we can write. Okay, now we use integration constant, integration symbol on both sides, and this one is dx in this side. In next step, whenever we apply the integration sign or integral, then constant part can be taken as outside. So we can write 1 upon n plus 1, and this part will be integration of dx raised to the power n plus 1, and in right hand side x raised to the power n into dx. So what is the final value? These two sign will cancel each other. So this become x raised to the power n plus 1 divide upon n plus 1. And this value is written as x raised to the power n into dx. So we can remember integration of x raised to the power n dx is equal to x raised to the power n plus 1 divide upon n plus 1. We can take example. So one question, what is the integration of 100 into x raised to the power 99 dx? We can take 100 outside because 100 is constant value, and x raised to the power 99 dx we can write. Next, 100. This time you can check from this formula the value of n is equal to 99. So we can write x raised to the power 99 plus 1 divide upon 99 plus 1. And don't forget to write the value constant c. And this one is 100 into x raised to the power 100 divide upon 100. So these two will cancel plus c. So final answer is x raised to the power 100 plus c. So this is the basic concept. So whenever we use the term, don't forget to write some integration constant c. So this is the first formula. Now, one by one, we will derive the formula by the help of differentiation only, and step by step, if you want, you can note it down. So first formula is integration of x raised to the power n dx is equal to x raised to the power n plus 1 divide upon n plus 1 plus c. So you can note it down. Move to the second part, second formula. I'm changing ink color. Okay. Second formula, you can check differentiation of sin x is equal to cos x. Already I have discussed this one. Differentiation of sin x with respect to dx is equal to cos x. So again we can write differentiation of sin x is equal to cos x into dx. Now we can use integration sign on both sides. Once we use integration sign, these two will cancel. So you can write integration of cos x dx is equal to sin x, and we need to use one integration constant c. So this is the third formula. Similarly, we can find the value for the third one. We know differentiation of cos x with respect to dx is equal to minus sin x. Minus sin x. So now we can write directly differentiation of integration of cos x. This time we need to write differentiation of cos x is equal to minus into sin x into dx. Or in next step we can write, taking integration sign on both sides, d cos x is equal to integration of minus sin x into dx. Now we can write, these two will cancel, sin x. So integration of sin x dx is equal to, this minus sign shift in left hand side, so it becomes minus cos x plus c. So till now we have discussed all these three formulas. So you can take the screenshot or you can note it down. Move to the fourth one. Once you move to the fourth part, we can write fourth formula, differentiation of tan x with respect to dx is equal to secant square x. Now we can write differentiation of tan x is equal to secant square x into dx. We can take integration sign on both sides, so these two will cancel. So we can write integration of secant square x dx is equal to tan x plus c. So no need to remember or learn this whole formula. Just try to find the what is the relationship between differentiation and integration. If we differentiate any function, then we get some value, then we can easily find the integral value. Like once we integrate that value, we will get this value. Next part, fifth formula. In fifth formula, we will try to find the differentiation of cortex. So differentiation of cortex with respect to dx is equal to minus cosec square x, minus of cosec square x. So if we write d cortex, then it becomes minus of cosec square x into dx. Now we can easily integrate both sides. Then we will get integration of d cortex is equal to minus integral of cosec square x into dx. Now these two sign will cancel, so finally we will get integration of cosec square x dx is equal to, shift the minus sign in left hand side, so it becomes minus cot x plus c. Generally when we use the trigonometric ratio like cos, cosec, so we use minus sign on left hand side or right hand side. Next part is secant x. So till now we have discussed few formula. In next video I will discuss the rest formula. So thank you everyone. Have a nice day. We will meet in next video.